Here we have a good exercise. Now we know that all costs in the factory are either fixed or variable, or some costs are mixed. In this factory, we have 3 data points in this table right here, and every data point that has a dollar sign would be a Y. And every data point then that doesn't have a dollar sign would be an X. Now you could plot these data points on a graph. Now in business you have graphs with 12 or 24 months of data, and you want to pick the high point and the low point. There may be an anomalous high or an anomalous low, and just ignore those. Pick the high and the low points that you think look normal, and then we're going to use that data to draw a line between those points, and that line will be our total cost curve. Remember, the y-intercept is the fixed cost. Then the x-axis is quantity. So for any level of production, we could predict the cost. So let's say at this level of production, what's the total cost? Total cost. We can predict the total cost. But we have to first create this equation or this graph. Now, the graph is one way of representing the equation. The other way of representing the equation is simply this: y equals a plus bx. It's the formula for a straight line. Y is the total cost, a is the fixed cost, and bx is the variable cost. More specifically, B is the variable cost per unit, and X is the quantity of units. So the high-low method says take the high point and take the low point and use the data of those to solve for the slope. How do you solve for slope? B equals slope in this formula, and slope is y2 minus y1 over x2 minus x1. That's sometimes called rise. That's the vertical y-axis. Over run. So let's do this calculation here. What's the larger y? It is 693. What's the smaller y? 4, 4, 5, 500. Whoops. I have a crack in my iPad screen. Okay. Now let's divide this by the changes in the x. Here's the bigger x, 6750, minus the smaller x, 2250. Do this math and it gives you 55. So B equals 55. 55 goes there. Now we need to solve for A, because we're taking the total costs they gave us, all this total cost data, and we need to separate it out into fixed and variable components. We've just figured out what's the variable portion of all this, the variable cost per unit. Now let's solve for A. Now let's pick one of these 2 data points. Let me clean this up a little bit. Let's pick the smaller or the larger, either one, but I usually pick the smaller because then I would work with smaller numbers. then this is the y value and this is the x value. So I can have a formula y equals a plus bx, and I can insert this for the y value, 445500. I'm solving for a. I just solved for b, which is 55. And x is this number, 2250. Because I used the low point. Because that low point is on the line, I can use that as the values of x and y. And then I can solve for a using simple algebra. And a, 321750. Now let me rewrite this into what we call a cost formula. The cost formula is, in the infinitive, y equals 321750 plus 55x. We're going to see this again in a future chapter on budgeting. Why is this useful for budgeting? Because for any value that you insert for x, you can predict your cost. And that's what budgeting is. You're trying to budget. You're trying to predict future costs. Well, if you know your cost formula, you can say, well, if our factory produces X amount of units, then Y will be the resulting total cost. So let's go to this variable cost. I solved that. Where's the variable cost? Right there. Fixed cost, I solved that. It's right there. And then question B says use the cost formula. Estimate the total cost for 3,240 units of production. Plug that in there and the answer is 499,950. There you go.